As we've seen throughout the years, there is so much that has already validated the flat circle maps. I would easily argue that a 24-hour light or sun in Antarctica, detached from the ground and water, could not possibly override all the evidence and proofs that has been gathered. Logic demands you need to take all observations and knowledge into account, and not just a single observation to determine truth. Now that the globe model has been thoroughly debunked and taken off the table, and by ignoring all the evidence that shows a 24-hour sun has never existed in Antarctica and requires it to be faked,
So there you go. That was a day in the life. It's about, I think 7:30 right now, as you can see. Still sunny and bright. There really is no true darkness at this point in the year. The sun sets, but there's so much reflective surface, so much ice out here that it never gets dark.
You know, one of the main issues being the 24-hour sun in the south. You know, Jaron has busted them time and time and time again, cutting out anywhere from 5 to 8 hours of footage, and then trying to claim that there is a 24-hour sun. He's written them, gotten responses from them. Basically their response is, well, that's not really our department, or, there's too much, it would take too much bandwidth, all these ridiculous excuses. So obviously if they aren't going to do it via a straight up CGI, which is entirely possible, then who's to say that they couldn't launch something up in the sky, with their little fake sun patent and make it at least appear that there's a local sun, and navigate it around in a circle. I don't think that's beyond the realm of possibility at all. And I think that, when it comes down to brass tacks, they may be prompted into doing something that desperate.
Well, look they can control balloons, right? And they can lift 8,000 pounds. So I'm pretty sure you could put a pretty bright ass light on a balloon, and if you can control its path, you just have it circle. I don't put it past them.
You could also use airplanes and any other flying technologies that we may have no idea that exists to carry a sun simulator. Another possibility is the use of lasers. Laser guide star systems are known facts, and so are the use of lasers for weather manipulation. Could focused beams possibly create an artificial sun? Could a sun be projected or reflected? All these technologies exist to pull off such a stunt.
I face the quakes, the wind, the fire. I've conquered country, crown and throne. Why can't I cross this river? I face the quakes, the wind, the fire. I've conquered country, crown and throne. Why can't I cross this river? Pay no mind to the battles you
show you a patent that I found that's going to explain what you're watching on this FAA.gov camera. This is the http abc.ams.faa.gov. This is a government camera. Watch this. Keep watching, and I'm going to show you the patent for it afterwards. And I'll show you the patent, and also I put it up on my backup channel last night. a shorter version, I instantly got a copyright strike and they instantly banned it worldwide. See that right there? You see that? You see that? See the sun up here? See this one falling away? We've never seen that before. We watch these cameras all the time. You seen that?
There is a dark theory about Samsung phones. You know how they always pride themselves on having a better phone than iPhone?
Yeah.
They say that their cameras are the best. They say you can literally point your camera at the moon and the quality is better than the telescope. They do really advertise like being able to zoom into the moon. So I watched this video by Shane Dawson and watched this clip. You see how the guy's able to zoom into the moon? Yeah, pretty good, right? Like it looks really good, right?
Yeah.
So Samsung actually just came out saying how they actually fake moon pictures on Samsung phones and they used AI to do this. But a guy made a video showing how Samsung's able to do this. Like, watch this clip. It's insane how he does this. He found a picture of a regular white circle and placed it on the other side of their house. They then zoomed in as much as they could to trick the phone into thinking it was a picture of the moon. The phone camera then replaced that white circle with a picture of the moon. It was just a white circle, and then it turns into the moon. Isn't that crazy?
Yeah.
Any white circle will turn into the moon, dude. That's a scam. Who knows what other technology's out there that's like deceiving us with AI.
Now, for an artificial sun, and China already launched one and showed an example. So people are showing videos that they took online, and they have a solar simulator. Now, this is all patented. There's images. This is online. You can find this information here.
Right? This is a real-world observation of the lighting pattern. So let's take a look. So we have the Gleason's map, and the sun was right there. We're going to put the sun right where they said the sun was. And we're going to lift it up and see, can it make that pattern? So we lift it up, and look, South America, California, everything except Australia and these islands are in the dark. Hey, that works on a flat Earth map. Let's take a look on a globe. So we got the globe here. So here's Australia. We'll put Australia right in the dark. So Australia and those islands are now in the dark. And we walk around to the other side. We have a single source light. And look, South America is in the dark. America's in the dark. It doesn't work. So let's reorient the globe. We're going to put South America right where they said it was. And we have it tilted correctly to the sun. Right? So South America's in the light. California is just getting dusk. And we go back over to the other side. And all of Russia is in the dark. There's too much. All of this, we're going to show you. All of that should be in the light. It should be like that. But it doesn't work on a globe, right? It doesn't work on a globe. This is the lighting pattern. This is redoable on our map, and it matches reality. One of them matches reality, and the other one doesn't work at all. What is the global excuse of that other than you're an idiot? Get out of your mother's basement. You know, that's all they have. They got nothing. They have nothing.
Yeah. It's limited to be 50% all the time daylight. And again, I'm just showing this to show you that this looks very similar when you look at the coverage here. You look at my lines. I'll go back and forth, but you can see it's very, very similar. I stayed within the full daylight. You can see that I didn't use any twilight, because you can see that point there, 0.6, right there in South America. It's pretty much the same spot. So now let's look at it on this type of a globe map. So we've got it daylight side and nighttime side. It's a mirror of the data. Like location 6 is a mirror of location 18 on the other side.
Wow.
So this shows you all the daylight on the nighttime side. So it's physically impossible to, for the day that's being shown for July 8th. Yeah, that's why they're saying, oh, it's 99% of the population. They ignore the surface area of what's going on, okay?
This is huge. There's no way around it. You can't say refraction. You have to have a second sun theory popping up. Something has to happen to provide that much sunlight. The dimensions of the globe would have to change drastically.
Right.
Wow.
Yep. So now this is kind of a summary. The actual sunlight coverage on July 8th, 2024 at time 11:15 UTC proves that Earth is not a globe/geode, but instead a circular level plane. Because on a heliocentric globe or geode, is it geometrically and physically impossible for sunlight to exceed 50% of the Earth's surface area. However, on July 8, 2024, at time 11:15 UTC, we have proven sunlight exceeds 50% of the Earth's surface area and is lighting up nighttime areas of the globe or geoid Earth when it should never occur. Therefore, this evaluation proves that Earth is not a globe or a geoid. So this is the coverage. You can see here's the sun. That's in Vilma, Africa. Location 1 is here, and 2 is going clockwise around. Okay, all the way around. You can see the geometry of things working out because it's intelligently designed, and that's why it shows the data there, because it's hitting all longitude lines.
So let's go to Antarctica together and report back to the world what we see.
The sun sets, the sun sets, the sun sets.
If you really want to use Antarctica, then use the landmass itself, not the sky. If you travel east along the ice wall, the globe demands to turn right continually. Flat Earth demands you turn left continually and for much longer, just as several old expeditions and detailed analysis of modern-day boat races suggest. Just as tsunami waves physically prove anyways, as we will see. Plane routes and emergency landings, time zones, undersea cable layouts, etc. also reveal the AE map and other circle maps like it. There's just too much to show without getting too sidetracked and overwhelmed for now. The fact of the matter is that this preponderance of evidence and facts goes to show that no matter what occurs in the sky there, it is occurring on a flat, circular, and motionless Earth. The water doesn't lie.
There's only partial amounts of times where you will have sun, but not for the full 24 hours.
Ever, right? Ever in Antarctica? It's never like that?
No.
Okay.
Never like that. For all the 30 years that we've been traveling, we haven't had any particular person actually come back and state that that is the case, where they found that for the full 24 hours there's basically been that particular time frame that the sun has been out.
Okay.
I know that it does, the sun does set a bit later within the evening because of it obviously being on the lost continent. But it's not that the sun will be out completely for the full 24 hours.
Okay.
Said, I've come to believe that the motion of the Earth cannot be detected by any optical experiment, though the Earth is revolving around the sun. Now, is the Earth revolving around the sun? Albert Einstein said that he couldn't prove it. There's no optical experiment. Now, so I can think of a few ways to test, to see if the Earth is moving. So in this video, I'm going to focus on the issue, is the Earth moving and is the Earth rotating? So Albert Einstein was saying that if you were on this wheel, right, if the wheel was moving, you wouldn't be able to do visual observations to see whether the protractor is moving or if the wheel was moving. Now I know that that's not true. The one way we can test is by using a automated pan rotation head for a camera. So that pan head we can set on a timer. It's going to do a rotation over a period of time. So how can this help us to test? So the first thing we need to see, let's say I use a pan tilt head. It's going to rotate 360 degrees in a 24-hour period. Doesn't matter where I stand, my position, my speed will be constant over that 24 hours. Now, it's not the same if I'm moving. If I'm rotating, my speed cannot be constant. So the person in the middle, He's turning to his right 360 degrees, but so is the person on the outside. But what's the difference? The motion will be detectable in your video footage. So let's look at our first piece of evidence. Now what this evidence is going to reveal, that the Earth is not moving. The Earth is standing still. So how do we prove this? Our first piece of evidence is from Fraser Gunn. He's got a YouTube channel, and his video is entitled The Takapo Night Sky, a 360 degree pan. So let's see what his footage looks like, and then we can analyze it. So here's his footage. His pan tilted, he's rotating to his left, and that's the night sky. So is the Earth moving, or is the stars moving? This footage reveals that the Earth is standing still and the stars are moving. Why? Because of his pan tilted. His pan tilted is rotating, and it's rotating to his left. So how does this footage then prove that the Earth is not rotating and that the stars are rotating? So let's have a look. If you are facing forward, right, you're going to do a rotation in a 12-hour period, and it's a 360 rotation. So what must happen? If you move forward and you rotate, you're rotating to your left 360 degrees, well, you can't see the Milky Way galaxy in front of you for 12 hours. You'll be facing the wrong way at the end of the rotation. And if you rotate to your right, well, you can't see the Milky Way galaxy at all during that 12-hour period. So your rotation must end when? At 6 o'clock in the morning. You're facing the wrong way. Right? So I find it a bit strange that Albert Einstein said that there's just no way that you can test it. Remember, we'll get given an answer and we're going to test it. So, evidence number 2. If I compare both camera movements, one to my left and one to the right, over a 24-hour period, 360 pan left and right comparison over a 24-hour period, well, your speed of the camera is not the same for both, and where you're facing can't be the same for both. Right, so we're still using the pan tilt head. We 24-hour period, 360 rotation. So let's analyze that a bit more. If I'm facing the moon, right, I've got a palm behind me, that's a marker, the moon is a marker, and we have time, a 24-hour period. So if I'm rotating to my left, the motion of the camera and the rotation speed of the camera will be different, because the rotation of the Earth has to be added to the rotation of the camera. It will become evident. So, in the opposite direction, I can only ever face the same direction as the moon, and the speed of my rotation will be different. Let's expand on this a little bit. If I am on a rotating platform, the platform's rotating, and I have a cutout palm. I put 2 palm trees on that rotation circle, and I'm standing on that circle. In front of me I have a moon, and to my left I have the sun. So from my perspective, as that platform rotates, what would I expect to see? So we're going to put a camera by this man, and we're going to see what he observes, and we can learn from this. Right, so if I'm rotating to my left, watch the ground, the motion of the platform. So the platform would swing out faster. Your speed cannot be the same. You would see the moon 3 times. When you start, as it swings by, you'd see the sun twice. And the moon, you would see it once again as it swings past when you end. But look at the motion of the land mass. Its speed isn't constant. The speed would pick up and slow down. Now, if I rotate in the opposite direction, from your perspective, the land mass must push sideways, then push backward. So the speed of the vegetation would change. Now the land mass would push to your left, you'd be pushed to the right, the land mass would push to the left, and then push forward, and the moon would constantly be in front of you. So if we apply this, we can see, we don't see this when we're using a 360 pan tilt head. When we use this equipment, what do we see? Well, everything rotates around your center point. Everything rotates evenly in the same position. It maintains its perspective. Everything maintains its perspective as the pan tilt head rotates. So, let's apply it to our train wheel. If I'm rotating in one direction and the protector is rotating in the same direction, you'll be able to tell. If you rotate in the opposite direction, there'll be a change in speed. It's logical. It's simple. So why did Albert Einstein say that he couldn't detect it? Someone said to me, do you know what the wave-particle duality means? I say, yes, it means Albert Einstein is making up a lot of stuff. If he can't even tell you if the Earth's rotating or not, no matter what he invents, how can I trust that? Is it just more made-up nonsense? He's just making stuff up. It has to be. So let's look at some more evidence. Evidence number 3. Right, if you see this, right, this is a long exposure of some stars. And this proves that the Earth is standing still and the stars are moving. So how can I say that? Let's have a look. If you had a rotating platform, you cut out some cardboard trees, right? And you hung up some lights in the vicinity. And if you were rotating, would you be able to tell if the stars were rotating or if you were rotating from this footage? No, you'd be able to tell if you were rotating or if the stars were moving. So what would you see from your perspective? Well, from your perspective, there would be a parallax shift between the lights. You'd be able to tell because there'd be a parallax shift. And the stars that are further away would move faster, but they would have to move at a 90-degree angle to the axis of your rotation. If you were rotating, the stars have to move at a 90-degree angle to the axis of your rotation. So therefore the stars can't move up and down like we see in this picture. The fact that you see the horizon tells you there's a problem, that the stars are moving. So how? Let's have a look. Remember, if you were moving and you were rotating, the evidence would be there. Your speed would be different. Your speed would change. How can your camera only pick up the rotation but not the sideways motion? And if you were moving, your speed won't be the same. You would slow down at this point, and then you would flip around and pick up speed. So let's have a look at that again. You would slow down, and that motion would be evident in your video footage. So the fact that we see the horizon tells me that the Earth is not moving, but the stars are moving. How? What does the horizon do for you? Well, if that's the horizon, your camera is lined up with Polaris, If you were rotating, how would you have to be rotating? Stop and think. Remember, we went to question things. That means you need to question and think. You'd have to rotate like this. That would be the angle of your rotation, because you are lined up with Polaris. The rotation would be around your camera. And if you moved your position, or you had a friend and he moved 5,000 or 6,000 kilometers to your right or left, you can't both be rotating, yet you film the same thing. So the answer is logical. Because both of you see the horizon, it implies that the stars must be turning. You're not moving, the stars are moving. The Earth is fixed, it is not moving. It takes photographs 360 degrees around him and he merges them into one image. So how does this help us? How can we use his image to understand if we are moving? Because if we are moving, remember, you'd have to be rotating like this every night as the Earth orbits the Sun. Right? So you won't be able to see this. You can't see this. Because remember, he takes a 360 pan at night around his position. So how does that help us? Well, what do you think? He wraps the 360 pan around him. It's at night time, so he's on the dark side. Would you see the Milky Way galaxy? And if that's your motion, really? I mean, freaking seriously.
I'll be looking at some footage that was filmed in the northern hemisphere near the North Pole. And this is the footage. We know that the guy used a wide angle lens. So there's some distortion, so we're going to just counter that. Make the horizon flat. He's using a wide angle. And what we're going to do is we're going to look at speed, light, and the motion. You see, what is actually going on in this footage? Is the Earth spinning, or is the man turning around? Now look at the light on the ocean. Look where the sun is, look at the shadows. And look how the mountains and everything rotates around the man. See, there's a problem. You see, if this man was in a spinning ball, the shadows and the mountain and the motion wouldn't look like this. What's happening is the sun is turning around the man, is orbiting around the man, and the man is simply turning his camera and pointing it towards the sun. So the Earth isn't spinning. The sun is orbiting above. That's why the sun is reflecting on the water as it is. Look at the shadows. So to help us understand this, imagine a train wheel. Right, the wheel turns on its axis. It's got a shaft, and the shaft is fixed off center. Right, so the shaft moves forward, it pushes the wheel, and the shaft comes back and pulls the wheel around. Okay, so the wheel rotates and the shaft is off center. So we're not don't focus on where the shaft is pointing. Look at the wheel and the position of the shaft. And so what do you see? Right? So basically this is what should be happening with the man who's filming the footage. So do you see? There's a couple of issues already that should be happening in that video footage that's not happening. So if we put a man on top of that shaft, the first issue is, as the man turns, he'd be crossing the light source, so the blue line in the middle, right, where the sun is. He'd be crossing over the the sunlight, backwards, left and right. But in the footage, the light is actually following him. Another issue is, look at the wheel itself. Think about his frame of reference. So from his frame of reference, the wheel should move out in front of him. The horizon can't stay the same. The horizon should rise up and move around him. Right? And watch, he should be moving over the blue line. You see how the blue line, which would be the reflection of the sunlight. Because the sun is fixed. So, the issue is the light itself, right, which would be the blue line. From his perspective, everything would be he'd be standing still, and the wheel would be turning around him. So the light would be swinging from his left and to his right, and the landmass should be pushing out in front of him and rotating back around him. And we don't see this in the video clip. You see, what we see in the video clip is that everything is moving in perfect position around him. Another issue is, look at, there's arrows here, so don't look at them, just look at the blue arrow, left and right. You see, as the person moves backwards, he also has to move to his right. In other words, if he moves back 1,000 kilometers, he has to swing to his right 2,000 kilometers. So his frame of reference wouldn't be turning around him, it would be pushing and sliding out towards his right. So, for example, the orange frame is where it started. As he moves around, because he's off center, remember? The landmass would push to his right. Watch the blue arrow on the right, left and right. Do you understand? And the footage doesn't show this. The footage, it's constant. So he's turning. He's not spinning around. He's not spinning off center. Do you understand? So from his perspective, the landmass would push to the right. And it's not. It's actually rotating around him. So the Earth isn't spinning. The man is turning and he's forming the sun, which is orbiting overhead. The second issue is we're going to look at the gold arrows. You see, if he's spinning off center, now watch, the gold arrows would point towards him, right? Because he's off center. So everything in front of him would actually be turning in front of him, because he's off center. So watch the arrows. Now they'll turn and face the other way. They're turning in front of him. So if he was spinning around a fixed axis, remember, for everything to turn around him, he'd have to be standing at the North Pole, exactly on the North Pole, so that everything turns perfectly around him. Or the Earth is standing still and he's just turning, forming the sun orbiting overhead. So this is what we see in the footage. He's turning and he's forming the sun, which is turning overhead. So look at the arrows, the gold arrows. They all keep the relative position. As he turns, everything stays fixed in its position to his frame of reference. So it's quite simple, really. Look at the sunlight on the water. I mean, it's just so obvious, you know. I mean, the Earth's flat and he's turning. There's nothing complicated. Nothing hard to understand in this. Those would be elongated and they would swing at 6 o'clock in the morning and 6 o'clock at night, late. It would swing the opposite way. Do you understand? In other words, the shadow should cross over like this. And they'd always be elongated. You can't escape that. And we don't see this in the footage. So if he's off center, the shadows further away would be spinning faster. You see? Watch the shadows. Remember, everything further away, it would be spinning faster from his perspective. All orbiting around their own fixed axis. Right? Does that make sense? Just look at the footage, look at the animation. And I mean, I didn't cheat here, just put the light source out, and it is what it is, you know. This is not difficult to understand. Look, you don't need maths for the stuff, really. It's just, it's logical. And we're going to get into a bit of maths later on, and I'll show you how people cheat and trick things. Right, so from a shadow point of view, remember he's off center. He's got his frame of reference, he's looking at the sun. When he gets furthest away, the sunlight can't light up the whole ground and be above and light up the surface. That's what would happen. You see, that's not what we see in the video footage. Look at this guy. His camera's locked down and he's filming the sun. He's in the same area. He's in the northern hemisphere, close to the North Pole. He's offset around the orbit of the sun, and the sun is overhead. Look at the shadows. How can the sun come back and now move back over his head? And look at the light on the water in the background. It's flat. And the sun is orbiting above this person filming. Right? We just have to learn to look. And this is what we see. He's off center and the sun is orbiting around him. And in his frame of reference, that's what he sees. So if he wasn't turning and watching the sun, the shadows would behave the same as we see in the video footage. We just have to learn to look and think. You know, the education system doesn't teach us how to think. It teaches us what to think, not how to think and reason. And if you do think and reason, well then, if we connect that video footage to his orbit, this is what he would be seeing. So he's turning, he's leaning over, now he's upright, and now he leans over to his left, and he's upright again, and the sun's on the horizon. Then he leans over to his right. So this footage is vertical with the man. From this angle, I'm just showing it to you from this angle in the animation. So now the issue arises. You see, if we center that image and we lock that image down on the horizon, what is the sun doing? Now look. See, the sun is simply moving up and then down. So the sun is moving up and down. Right? So the sun, if we can use another term, is zigzagging up and down. So what is causing that zigzag? So I'll say no. What's causing that is the tilt, the 23.4 degree tilt of the earth, because the man is leaning backwards and now he's leaning forwards. Then he leans backwards and forwards, that's what's causing the tilt. Well, then you have a big problem. You see, the man, if the tilt, if that is caused by leaning backwards and leaning forwards, you see, he's leaning the same distance to the left and to the right. How can he only register his backwards and forwards motion? You see, the North Pole is in the center and he's spinning around the North Pole. it would have to register motion, left, backward, forward, his complete motion. You can't just film the up and down motion because he's not just moving backwards and forwards. He's moving in a circle. So, the sun then, if he was on a spinning ball, should move in a circle. Now listen carefully. Some people, even in the flat earth community, don't want you to look at this video footage and analyze it. They'll say, no, the sun is too far away for it to show any motion. The point is, it is showing motion in his video clip. The sun is moving up and down. So you cannot argue then that the sun is so far away that it doesn't show any motion. The sun's motion is registered, it's up and down. So that argument goes out the window. So now I've created an animation, exactly what the man would see. Now I've locked a camera onto him. This is the same motion that we saw earlier, and that's simply what the cameraman would see. So the cameraman would see the sun moving in front of him like this. And the earth and the mountains is turning around the man. The numbers there, 1, 2, 3, 4. They're orbiting, they're rotating around him. This is not what we're seeing in the footage. We do not see this. What we are seeing is a man who's turning and he's forming the sun orbiting around his position. So I've lined up when the sun is on the horizon, and he's slightly off-centered. So the sun goes up and the sun goes down. So now what is causing the sun to move up and down? See, the sun is moving up and down. So how's that work? What is causing that? Well, it's the sun orbiting around him. Now when I look at this in detail, you see the sun's motion is in a straight line. Watch. The sun's path is in straight lines. If I take those lines out the way, you just don't notice it. So, the man's rotating 360 degrees. Every time it rotates, the sun goes up and down. It forms a triangle. Each side is 12 hours. So each triangle is 24 hours. The base of that triangle is 360 degrees. So over a week, that would make it 2,520. Now if you read your Bible, you'll understand that 7 times is equal to 2,520 in Revelation. But that's another issue. So now if I take those triangles, and I put them in a circle, I get this image. I get this pattern. So the top triangle would be a day, right? And each line would represent a week. Right. So it's not difficult to understand. This is the image that many of the people use in secret societies use to represent the sun. And so why? Well, now if I take that image, the sequence of the sun turning, if I take that sequence of the sun up and down and I put it in an orbit around this man, now there's no trickery here. I've just simply taken that image and I'm rotating it around. Now watch how the sun follows those lines. So after each rotation, the sun now is on the next line and now makes a new triangle. So what does this teach us? that there is perfect precision in the motion of the sun and the moon and the stars, that there is a creator, that is undeniable that there is a creator. And they're trying to hide that from us. You see, they give us nonsense that the earth is a spinning ball. But we know that all the trees grow towards the sunlight. So how does this work? This tree's at the equator. 6 months later, when the sun's on the opposite side, how do trees grow towards the sunlight? I'll tell you, gravity. Gravity makes the tree grow upright. The trees, plants grow towards the light. How does that model and the plants, nature that we see around us, how does it fit onto the ball? It does not. We are simply being lied to. They don't want you to see the perfection in creation, because there's a creator, and that is undeniable. So if I look at the pattern in plants, you'll see that plants spiral out when they grow. And this spiral pattern that we see in plants perfectly matches the sun that is orbiting above the plants. You see, the plants are all at the same angle to the sun. The sun's above them, and they all spiral outward. If we take our time and we look at the creation, and it's awesome, we'll start to see the creator's hand. Look at this tree. This tree is split, and it's split in a spiral because it's twisting, because the sun is orbiting overhead. So if we just look at the patterns that we have in creation, and we put them together, we will see that it all makes sense, because the sun is orbiting above the flat earth. The path of the sun.
29th of July 2015. A fire has broken out in a cooling fan in an inaccessible cargo compartment on a Boeing 777 midway between Hong Kong and Los Angeles. There is smoke in the cabin, and the captain has told the passengers to put on their life jackets in preparation for an emergency sea landing. Ethan Williams is recording the whole terrifying ordeal on his phone.
So it's actually dark, and I remember looking outside of the window, and you could see that they were jettisoning some fuel out of the side of the wing.
The forces on the landing gear of a plane are much greater during touchdown than takeoff.
Across the flight, so we're what I perceived to be the middle point, and there was nothing but ocean around us. I remember actually looking on the in-flight map to see where we were, and yeah, there was nothing but ocean around us.
And a nighttime sea landing on the icy waters of the North Pacific is not a comforting prospect.
My understanding of landing into the ocean was it was more of a crash as opposed to a landing.
It's estimated that 30 commercial aircraft have ditched at sea over the last 40 years to withstand the weight of a fully fueled plane when they come into land.
The wing holds all the fuel, and that structure is set up to a specific weight and bending motion. Well, with that much fuel landing that airplane, it's too much for that. You must get rid of that gas. You have to either dump it or burn it off. So that's an absolute requirement.
But when I saw the fuel coming out, I'd say it kind of reaffirmed that we were in a real situation, and I realised it was going to be quite serious. Yeah, I think we were sat there at this point for maybe kind of around 10-15 minutes, and then the pilots come over the radio, and you can definitely tell she was a lot calmer in her voice.
The pilot tells the passengers they are setting course for a US military airbase on Shemya, a tiny weather-beaten island more than 1,000 miles from Anchorage in Alaska.
I remember not knowing where this place was, and just thinking, right, great, it's a land, doesn't really matter where it is, what it is, as long as we can land normally there. We started to look for where this island was on the map, and you can kind of see this island kind of appearing and getting a bit closer. It was kind of just a relief to know that there was actually some land around us, and somewhere we could potentially have a normal landing.
So that's really good news, guys. We're over to Shemya, it's going to be a normal landing, not a water landing. So that's really huge news.
This is a huge relief to Ethan, but also a big surprise. He hasn't expected that a flight from Hong Kong to Los Angeles will go anywhere near Alaska. The reason it did is mainly because of the way flight paths are plotted to account for the curvature of the globe.
If you look at a flat map, and you draw a line between Hong Kong and Los Angeles, you go straight across the water, it's like, that makes sense. If you look at a flat map, and you draw a line between Hong Kong and Los Angeles, you go straight across the water, it's like, that makes sense. But you look at a globe, and you draw a straight line from Hong Kong to LA, and then you take it off the globe and then flatten it out, it's an arch. So it's called the Great Circle Route. If you looked at that on the Great Circle, it's not that far from Alaska in the first place. But you look at a globe and you draw a straight line from Hong Kong to LA, and then you take it off the globe and then flatten it out, it's an arch. So it's called the Great Circle Route. If you looked at that on the Great Circle, it's not that far from Alaska in the first place.
The plane makes its final approach to the remote Alaskan island.
At this point, we're actually going down quite fast. I can feel the air pressure changing, my ears are popping quite severely. It's actually quite painful.
Flight CX-884 is still overburdened with fuel, so the captain prepares the passengers for a potentially perilous landing.
So as we were coming down, it was still pretty dark. You couldn't really see much or anything out the window. I think they told us that there was a chance of the brakes catching fire because of how heavy we were on landing. When we landed, it was quite a rough impact. We landed quite hard, and it was actually very heavy on the brakes as well. And it was just a absolute massive lights flashing towards us and rushing around.
The brakes and the rest of the plane survive. But it's not over yet. The 276 passengers are now stranded on a 2x4 mile island at a largely inactive military airbase with nothing to do and nowhere to go but the plane itself. Ethan sets about editing a video of his flight from hell.
So I thought, well, I can kill this time. I have my laptop with me, I have the footage. Let's start editing it and finalise the video within a couple of hours of being there.
Ethan and the rest of the passengers then fly the 1,500 miles to Anchorage in the same plane they just limped into the airport on 6 hours earlier.
That we didn't know what the issue was on the plane, and then we were still flying on the same plane. And actually when we took off, you could smell some burning. And then when we finally landed in Anchorage in Alaska, it was, okay, right, we're done with this plane, let's get off it. And it was a huge sense of relief to kind of be off and at least somewhere where we were back on relatively normal land.
Now, you might have some sheeple that tell you that when you see the trails coming out of the ends of the wings instead of out of the engines, that they're dumping fuel, okay? Take a look at this. I'm gonna freeze it right here so you can see that this is not coming from the four engines. It's coming out of nozzles on the wings. Now, like I said, you have these sheep that are asleep that will tell you, oh, it's dumping fuel out those nozzles. It's dumping fuel out those nozzles. Well, I'll just say that you're a special kind of asleep if you think that that plane is dumping all that fuel out going across that sky. That's what I'm telling you. If you think all that is fuel coming out of that plane, he wouldn't even make it to the airport. You have lost your sheeple mind. And if you do believe that nonsense, then you have to believe that all the planes flying over you all day long are just dumping fuel. All you gotta do is Google it, check it out. Planes dump fuel, also known as fuel jetsoning, infrequently, but it's not an uncommon occurrence. Pilots typically only dump fuel in rare emergency situations when the plane needs to land as soon as possible. Very simple. Planes don't do this every day, all day long. Planes don't dump fuel every day, all day long. Stop listening to these fools. Okay, now if you look right here, that is a chemtrail. Now if you look over right here, you know what that is? That is a contrail. It's really simple. Chemtrail, which will linger in the sky for hours and hours and hours long after the plane is gone. And this one right here will not, because it is a contrail. And you'll see another one right up here. Check this out. That is a chemtrail. It lingers and stays in the sky all day. Okay, that's what a chemtrail does. But a contrail, condensation trail behind a plane, a regular plane that is not a chemtrail plane, it disappears shortly after the plane goes by, as you can see right here. Chemtrail, contrail. Big difference, people. Big difference.